MIT. This video will show the solution to the first problem in the type 2 on assessment on mathematical modeling. So it says a farmer wishes to fence a rectangular area along the river bank. No fence is required on the side adjacent to the river, and the material for the fence costs 5 peso per meter for the side parallel to the river and 10 peso per meter for the other two sides. If the farmer has a 20,000 peso budget, find the dimensions of the lot that will have the largest possible area. To solve any problem, usually if it's a long word problem, you take each information one at a time. So you can go sentence by sentence and then try to translate the sentences or each sentence into a mathematical expression. So in this case, the first sentence is a farmer wishes to fence a rectangular area along the riverbank. So we know, we can picture that in our head, or you can draw a diagram showing a rectangular area along the riverbank. So say this is the part of the river, and then you're going to fence or to fence a rectangular area. So take note that in the second sentence, no fence is required on the side adjacent to the river. So this side does not require fencing. And then the next statement says that the material for the fence costs 5 peso per meter for the side parallel to the river and 10 peso per meter for the other two sides. Before we translate this statement, we can let some variables for the length and the width of the rectangular area. So let's say let x to be this side, so this is also x, and let y to be the length. So if it says that the material for the fence, so basically you're going to spend fencing this material, this rectangular area, and each side or the sides have different costs. So for the side parallel to the river, so this is the side parallel to the river, it will cost you 5 peso per meter. So if the length of the side parallel to the river is y, then you are going to spend 5 peso times y for this side alone. And then for the other two sides, they are the same, x and x, you are going to spend 10. So side and this side together is 2x, but for the 2x you are going to spend 10 per meter. So adding this together will be your total expenses. But note, it says that the farmer has a 20,000 budget, so you don't want to go beyond this, and as much as possible we want to spend exactly 20,000 pesos. So expenses for the y side and expenses for the two sides x, 2x, times the cost 10 per meter, together this can only be 20,000. So just to simplify the equation, 5y, this is 5y plus 20x is equal to 20,000. Okay, now take note that we want to find the dimensions of the lot that will have the largest possible area. So it is talking about finding the largest possible area, and since this is a rectangular area, we know from geometry that for a rectangle the area is equal to length times the width. So if this is our length and this is the width, then the area in terms of x and y is equal to x times y, or y times x, the other way around. So let's write that in the proper way, y times x. Now in solving problems like this, as much as possible, we need to express an equation in terms of one variable only. So we are dealing with this equation, 5y plus 20x equals 20,000, and an area equals to y times x. So you have a choice, either you change the y into an x, or you change the x into a y. So, but looking at this equation, by the way, we can see a 5, a 20, and 20,000. Each number is divisible by 5, so we can divide by 5 first. So divided by 5, divided by 5, divided by 5. So this will become y plus 4x is equal to 20,000 divided by 5 is 4,000. Okay. Now, again, going back to our goal, we need to replace one of the letters here. As you can see, this is already y and this is 4x. Intuitively, or I mean by just observing, this equation can be changed into y equals 4,000 minus 4x, and this is equivalent to y. So the area equals y times x can be expressed as 4,000 minus 4x times the x. And if you simplify this, this will give you 4,000x minus 4x squared. And at this point, you can already rename your function as a of x. Now, how do we find, because the question is, you have to find the dimensions of the lot that will have the largest possible area. So all we need to do is to find that x. So we have to find this x in which this area will be the largest. If you look at the equation, this is a quadratic equation. And a quadratic equation has its graph is a parabola. And a parabola can either, or is either parabola opening downwards or it is opening upwards. And this will happen if the coefficient of x squared is negative. And this is the graph of the parabola when the coefficient of x squared is positive. Now, as you can see, in the equation we have negative 4x squared. So if we graph this function a of x, this will be the graph. Okay. So as you can see, there is in this parabola there is a maximum point. So if the a of x equals 4,000x minus 4x squared will have this graph, then we are looking for that x that will give us this point. And recall that this point is actually the vertex of the parabola. So to look for x, what we can do is just simply find the vertex of the parabola. Now, the formula for the vertex, so vertex of a parabola can be obtained. So the x value can be obtained through negative b over 2a, and the y value can be obtained through 4ac minus b squared over 4a. So I will not be discussing the derivation of these formulas, but let's just apply this to the problem. So we're looking for dimensions, we're looking for x. This is the x. Okay, now this, do not confuse yourself, this is usually the y, but the y here is different to the y in this equation. Okay, it simply means if x is the dependent independent variable here, then this is your 4ac minus b squared over 4a. This is actually the area. Okay, so to find the maximum area, we need to find this x, which is negative b over 2a. So where are we getting the b and the a? So remember, a is the coefficient of x squared, b is the coefficient of x. So negative b over 2a is equal to negative of 4,000 divided by 2 times negative 4. This is equal to negative 4,000 divided by negative 8. And if we divide the 2, this will give us positive 500. So this is the x that we need. So x must be equal to 500. So we were able to find x. Okay, the width of the rectangle should be 500. Now, how do we find the value of the y? What is the length? Note we have this equation. Y is equal to 4,000 minus 4x. So now that you know the value of x, to find the y, you simply substitute the x, which is 500. So 4,000. So this is 4,000. 4 times 500 is 2,000. So that makes y equal to 2,000. So the x must be 500 and the y must be 2,000. So these are the dimensions in order for us to get the largest possible area. Now, if in the future you'll be asked to find the largest possible area, then given these dimensions 500 and 2000, just use the formula length times width, that is 500 times 2000. Okay? So the final answer to this question is the dimensions are 500 by 2000. Okay? So I hope that the explanation is clear. So dimensions 500 and 2000 in terms of the units. The problem use, sorry for that, the problem use meter, so 500 meters and 2000 meters. That's it. Okay.